An algebraic fraction is one where the numerator and denominator are both polynomial expressions. This is an expression where every term is a multiple of a power of x, like 5x to the fourth plus 6x cubed plus 7x plus 4. The degree of a polynomial is the power of the highest term in x, so this is a polynomial of degree 4. The number in front of x in each case is the coefficient of that term, so the coefficient of x to the fourth is 5, the coefficient of x cubed is 6. Now look at these fractions. X over x squared plus 2, or x cubed plus 3 over x to the fourth plus x squared plus 1. In both cases, the numerator is a polynomial of lower degree than the denominator. X as against x squared, x cubed as against x to the fourth. We call these proper fractions. With other fractions, the polynomial may be of higher degree in the numerator. For instance, x fourth plus x squared plus x over x cubed plus x plus 2, or it may be of the same degree, such as x plus 4 over x plus 3. We call these improper fractions. I'd now like to look at how we add and subtract fractions. Take, for instance, these two fractions. In order to add these two fractions together, we need to find the lowest common denominator. In this particular case, it's x minus 3 times 2x plus 1. So we say that this sum is the equivalent of, in the denominators, we are going to have x minus 3 times 2x plus 1. In order to get from there to there, we multiplied by 2x plus 1. We've multiplied the denominator by 2x plus 1, so we must multiply the numerator by 2x plus 1. And in order to get from here to here, we've multiplied the denominator by x minus 3, so we've got to multiply the numerator by x minus 3, and this gives us just x minus 3. And now we need to collect up. The denominators are the same, so we can just write x minus 3 times 2x plus 1. And on top, we have 2 times 2x is 4x, minus x gives us 3x. And we also have 2 times 1 is 2, minus 3 is plus 3, so 2 plus 3 is plus 5. And that is the answer to that sum. Sometimes in mathematics we need to do this operation in reverse. In calculus, for instance, or when dealing with the binomial theorem, we sometimes need to split a fraction up into its component parts, which are called partial fractions. Let's take the sum that I've just dealt with. We got the answer 3x plus 5 over x minus 3 times 2x plus 1. So how do we get this back to its component parts? Well, we only have two factors in the denominator, x minus 3 and 2x plus 1. So it must be something over x minus 3 plus something over 2x plus 1. And what are these somethings? They can only be plain numbers, because if they involved x or powers of x, then these would be improper fractions. So we're quite entitled to say that 3x plus 5 over x minus 3 times 2x plus 1 is a over x minus 3 plus b over 2x plus 1, where a and b are just plain numbers. The next thing to do is to multiply everything through by what's on the bottom, x minus 3 times 2x plus 1. If you multiply the left-hand side by that, we just get 3x plus 5 equals a over x minus 3 times x minus 3 times 2x plus 1. The x minus 3's will cancel, and we're just left with a times 2x plus 1. b over 2x plus 1 times x minus 3 times 2x plus 1. This time the 2x plus 1's will cancel, and we're just left with b times x minus 3. Now this is an identity, which means that it is true for all values of x. If this is so, then we can substitute special values for x, and it will still be true. For instance, if we make x equal to minus a half, this bracket will become 0 and a will disappear. If we make x equal to 3, this bracket will become 0 and b will disappear. And I'm going to do just that. If x equals minus a half, we get 3 times minus a half is minus 3 over 2 plus 5. That is 0 equals b times minus a half minus 3. This is just 7 over 2, and we get 7 over 2 equals, this is minus 7 over 2, minus 7 over 2b. So b is equal to minus 1. I'll write this line in again. 3x plus 5 equals a times 2x plus 1 plus b times x minus 3. This time I want to try and find a, so I'm going to put x equal to 3. If x equals 3, we have 3 3's are 9 plus 5 is 14. 3 2's are 6 plus 1 is 7. That is going to be 0, so b will disappear. So a is equal to 14 divided by 7. In other words, a is 2. We already had b equal to minus 1. So what do we have now? I had 3x plus 5 over x minus 3, 2x plus 1 times 2x plus 1 equals a over x minus 3 plus b over 2x plus 1. Since a is 2 and b is minus 1, we can say that this is 2 over x minus 3 minus 1 over 2x plus 1, which is the sum that we started with, and we have now broken this back into its component parts called partial fractions. We'll do another example. Let us say that we have to express 3x over x minus 1 times x plus 2 in partial fractions. Again, we look at the denominator. The factors in the denominator are x minus 1 and x plus 2. So we say that this expression is equal to a over x minus 1 plus b over x plus 2. We multiply through by x minus 1 times x plus 2. On the left-hand side, this just gives us 3x. On the right-hand side, a over x minus 1 times x minus 1 times x plus 2. The x minus 1's cancel out, and we're left with a times x plus 2. b over x plus 2 times x minus 1, x plus 2. The x plus 2's cancel out, and we're left with b times x minus 1. This time the special values that I'm going to take are x equals minus 2, because that will make that 0 and thus eliminate a, and x equals 1, which will make that 0 and thus eliminate b. If x equals minus 2, we get 3 times minus 2 is minus 6. That is 0, so a disappears. Minus 2 minus 1 is minus 3, so this is minus 3b. So b equals minus 6 divided by minus 3 equals 2. I'll write this expression in again. This time I'm going to put x equal to 1. 3 times 1 is 3. 1 plus 2 is 3, so we get 3a. 1 minus 1 is 0, so b disappears. If 3a equals 3, then a is going to equal 1. So we've got a equal 1. We already had b equal to 2. I'm now going to write the whole expression in again. We have 3x over x minus 1 times x plus 2 equals 1 over x minus 1, because a is 1, plus 2 over x plus 2, because b is 2. And that is the answer. Sometimes the denominator is more awkward. For example, to express 3x plus 1 over x minus 1 squared times x plus 2, there are actually 3 possibilities for a denominator in the partial fraction. We've got x minus 1, x plus 2, but there's also the possibility of x minus 1 squared. So we write down a over x minus 1 plus b over x minus 1 squared plus c over x plus 2. Again, we multiply through by the bottom line here. So we get a over x minus 1 times x minus 1 squared times x plus 2. One of the x minus 1's will cancel, leaving us with 3x plus 1 equals a times x minus 1 times x plus 2. b over x minus 1 squared times x minus 1 squared times x plus 2. Both of the x minus 1 squareds will cancel, leaving us with b times x plus 2. And then we have c over x plus 2 times x minus 1 squared times x plus 2. This time the x plus 2's will cancel, leaving us with c times x minus 1 squared. Again, the special values. X equals 1 will make this 0, so a will disappear, and it will make this 0, so c will disappear. If x equals 1, we have 3x plus 1 is 4. That's 0, so that expression disappears. 1 plus 2 is 3, so we have 3b. This is 0, so this disappears. So we have 4 equals 3b, giving b equals 4 over 3. If x equals minus 2, we have minus 2 times 3 is minus 6, plus 1 is minus 5, equals, This is 0, so this disappears. This is 0, so this disappears. Minus 2 minus 1 is minus 3, squared is 9. So we have minus 5 is 9c, which gives us c is minus 5 over 9. We now need to find a. I'm just going to write this expression out again. I've written the expression following C out like that because in a minute I'm going to multiply it out. Unfortunately, there's no special value of x that will eliminate b and c to give us a. We can use any special value. We could use x equals 0. This would give us an equation in a, b and c. Since we already know b and c, this would give us a. But I'm going to use a different technique, one called equating coefficients. And to do that, I've got to multiply this lot right out. So we get equals a, and we have an x times an x for x squared. We have a minus 1x plus 2x, so that gives us plus x. And we have minus 1 times 2, which gives us minus 2. And then plus b, x plus 2, plus c, x times x is x squared. We have a minus x and a minus x, so that's minus 2x. And then minus 1 times minus 1 is plus 1. I'm now going to collect up all the terms. For instance, we have an a times x squared here, and we have a c times x squared here. So we have a plus c times x squared altogether. We also have an a times x, a b times x, and a minus 2c times x. A plus b minus 2c times x. And finally we have minus 2a, 2b, and c. So the constant becomes minus 2a plus 2b plus c. Now, so we have 3x plus 1 equals this line. But in this line we have a term in x squared. 3x plus 1 doesn't have anything in x squared. But this is an identity. It must be true for all values of x. And the only way that this can be true is for a plus c to be 0, so that x squared disappears on this side. So we can say that a plus c equals 0. We already know that c is minus 5 over 9. So in order for a plus c to be 0, a must be plus 5 over 9. And we already worked out b as being equal to 4 over 3. This means that we can write out the solution to the whole problem. 3x plus 1 over x minus 1 squared times x plus 2 equals a 5 over 9 x minus 1 plus b is 4 over 3, 4 over 3 x minus 1 squared. C is minus 5 over 9, so we have minus 5 over 9 x plus 2. Another case we must consider is where the denominator contains a quadratic that can't be factorized, as in 5x over x squared plus x plus 1 times x minus 2. If we're to express this in partial fractions, the two denominators are going to be x squared plus x plus 1 and x minus 2. When the denominator is x squared plus x plus 1, we have to consider the possibility that the numerator can contain a term in x, because the numerator would still be of lower degree than the denominator, and this would still therefore be a proper fraction. So we write ax plus b over x squared plus x plus 1 plus c over x minus 2. As before, we multiply this out, so we get that 5x equals ax plus b times x minus 2 plus c times x squared plus x plus 1. One special value we can use is x equals 2. And if x equals 2, we get 5x, 5 2s are 10. This is 0, so this all disappears. And we get 2 2s are 4, plus 2 is 6, plus 1 is 7. So 10 equals 7c, giving c equals 10 over 7. Unfortunately, there's no value for x that will enable us to get rid of c, so we're going to have to use the technique of equating coefficients. I'll write this out again. In order to equate coefficients, I'm going to have to multiply this out. Ax times x is ax squared. Ax times minus 2 is minus 2ax. B times x is bx. B times minus 2 gives us minus 2b, plus cx squared plus cx plus c. Again, I'm going to collect like terms. So, for instance, for x squared, we have ax squared and cx squared. So we have a plus c x squared. For x, we have a minus 2a, a b, and a c. So minus 2a plus b plus c x. And for a constant, we have minus 2b plus c. We still need to find both a and b. For two unknowns, we need two equations, so we are going to have to solve for two different coefficients. Now the left-hand side is just 5x, so there is no coefficient in x squared. In order to eliminate x squared, we can say that a plus c equals 0. We already know what c is, 10 over 7. In order for a plus c to be 0, this will make a minus 10 over 7. The left-hand side also has no constant coefficient, so that means that this expression must be 0. So we say minus 2b plus c equals 0, giving us c equals 2b, or b equals c over 2, which gives us b as being 5 over 7. So we have a equal to minus 10 over 7, b equal to 5 over 7, and c equal to 10 over 7. This means that 5x over x squared plus x plus 1 times x minus 2 is equal to ax, which is minus 10 over 7x, plus b, which is 5 over 7, all over x squared plus x plus 1, plus c, which is 10 over 7, over x minus 2. And I'll now tidy this up. The 7 comes down to be multiplied by the x squared plus x plus 1. So we get minus 10x plus 5 over 7 x squared plus x plus 1 plus, and again the 7 comes down, 10 over 7 x minus 2 equals, and to finish it off, we need to take 5 out of this expression as a factor, which gives us 5 times minus 2x plus 1 over 7 x squared plus x plus 1 plus 10 over 7 x minus 2. So far I've only dealt with proper fractions where the numerator is of lower degree than the denominator. I'd now like to look at an improper fraction. Let's express 4x cubed plus 10x plus 4 over x into 2x plus 1 in partial fractions. The numerator is of degree 3. The denominator, if you multiply the x by the 2x, you get 2x squared. So the denominator is of degree 2. This means that this is an improper fraction. What this means is that if you divide the numerator by the denominator, you're going to be dividing a term in x cubed by a term in x squared. So you could get a term in x, which means that we have to write down ax. We may also get a constant term, so we have to write down b. Then we can do our fractions. If I now multiply through, I get ax times x times 2x plus 1. So we get 4x cubed plus 10x plus 4 equals ax squared times 2x plus 1 plus bx times 2x plus 1 plus c times 2x plus 1 plus dx. Using special values, if I use x equals 0, then the term, the d, the b, and the a are all going to disappear, and I'm just left with c. So if x equals 0, x cubed is 0, x is 0, I just get 4 equal to 2x is 0, so it's just c. So we have c equal to 4. The other special value is x equal to minus a half. If x equals minus a half, this is 0, so this will disappear. This is 0, so this will disappear. And this will disappear, just leaving me with d. So I get minus a half cubed is minus an eighth. So I get minus 4 over 8 plus 10 times minus a half, which is minus 10 over 2 plus 4 equals d times minus a half. I'll just write that down again. Minus 4 over 8 minus 10 over 2 plus 4 equals minus a half d. Minus 4 over 8 is just minus a half. Minus 10 over 2 is minus 5, plus 4 equals minus a half d. Minus 5 plus 4 is minus 1, so I've got minus 1 and a half equals minus a half d. Minus 1 and a half is just 3 times minus a half, so this gives us d equal 3. Special values won't give me a or b, so I'm going to have to equate coefficients. This means I'll have to write this expression out again. 4x cubed plus 10x plus 4 equals ax squared times 2x plus 1 plus bx times 2x plus 1 plus c times 2x plus 1 plus dx. I'm now going to multiply this out. Ax squared times 2x is 2ax cubed. Ax squared times 1 is just ax squared. This gives me 2bx squared. This gives me bx. This gives me 2cx. And this gives me c. And then plus dx. And collecting terms, we only have one term in x cubed, so that is just 2ax cubed, plus we have two terms in x squared, a and 2b, we have three terms in x, b, 2c and d, and finally the constant term c. Now look at the term in x cubed. We have 4x cubed on the left and 2ax cubed on the right. This means that 2a must be equal to 4, giving us a equal to 2. Now look at the term in x squared. There is no term in x squared on the left, and on the right we have a plus 2b. This means that as there isn't a term in x squared on the left, a plus 2b must be equal to 0. So we have a plus 2b equals 0, which means that a equals minus 2b, which means that b equals minus 2 over 2 equals minus 1. I'll just write those values in again. A equals 2, B equals minus 1, C equals 4, D equals 3. So if we take our original expression, 4x cubed plus 10x plus 4 over x times 2x plus 1, this is equal to ax, so 2x minus b plus c over x, so that's 4 over x, plus d over 2x plus 1, which is 3 over 2x plus 1.